Think all the way back to Lesson 1, when we talked about the network switch. That background really starts to help us now. To be precise, the term bridge describes the Layer 2 device we're discussing today. However, most people actually call a bridge a switch. Now, this is because the capabilities of today's bridges greatly exceed what they were originally designed to do. And, just to confuse things some more, the term switch can also be used to describe a router. You know, sometimes it seems that the more we define network devices, the worse it gets. To help eliminate this terminology problem, the names Layer 2 switch and Layer 3 switch have now become popular. So the term Layer 2 switch refers to a bridge, while a Layer 3 switch is a router. I hope this helps minimize the confusion. Anyway, back to today's lesson. What exactly does a bridge do? A bridge is used to expand the size of a network, though, as you remember, repeaters do this too. The difference between them is that while a repeater just repeats the original packet, a bridge actually copies, reads, and then recreates a brand new packet. This avoids the packet degradation often associated with repeaters that simply repeat packets over and over and over again. A good analogy is to compare repeaters and bridges to a copy machine. What would happen to a page of text if you made a copy of a copy of a copy, and on and on? Eventually, the copies would get so fuzzy they would be unreadable. But if each copy were made from an original, all copies would have the same quality. The difference in packet quality with repeaters and bridges is similar to this analogy. A bridge makes a copy of the original packet every time, so the quality stays high. Next, a bridge can overcome station count limits. All LAN protocols have a maximum number of users allowed on one segment. This number can range from a few hundred to over 1,000. While newer networks no longer contain shared segments, the bridge was originally designed as a way to break up large, heavily populated networks into smaller, less populated segments. This is called microsegmentation and is still used in many existing networks. Next comes the bridge's store and forward capability. This capability is one of the foundations of bridge operation. Just as the name implies, store and forward means that the bridge has the ability to store a packet and then forward it later. Let's look at an example. The bridge receives a packet from one port, let's say port 4, and the packet is destined for port 9. If port 9 happens to be busy transmitting or receiving data, the bridge stores the original packet. Then, when port 9 becomes available, the bridge forwards the packet. Now, this may sound slow, but the store and forward process can occur tens of thousands of times a second. Bridges also keep local traffic local. This is one of the other foundations of bridging. Most bridges, unlike repeaters, track the location of all devices connected to them by identifying which MAC addresses are located on which ports. This way, the bridge is able to make intelligent decisions when forwarding packets. So, if a bridge knows device AA is located on port 1, it will only send a packet destined for port A to port 1. As I've mentioned earlier, bridges use the spanning tree protocol. This protocol allows bridges to exchange information concerning where other bridges are located and helps the bridge define the network topology. Next, the bridge may be capable of supporting multiple speeds for a single protocol. For example, Ethernet can support 10 megabits per second, 100 megabits per second, and 1 gigabit per second. When communication is required between ports that support different speeds, a bridge acts as an intermediary between the speeds and adjusts the traffic to the port speed by buffering it as required. The bridge can also translate traffic between devices using different Layer 2 protocols like Ethernet, Token Ring, FDDI, and others. Translation is accomplished by taking the data portion of one frame and inserting it into another. While the actual translation process is a bit more complex, this explanation is sufficient, well, at least for now. While this is a summary of basic bridge functions, it's important to realize that not all bridges support every capability we've discussed. However, all bridges do keep local traffic local and store and forward packets.